Hi. So some of you have had some difficulty with unit conversions and dealing with energy, with efficiency of appliances. So I thought I'd do a worked example that had kind of four components and talk you through it and see if that, and hopefully that'll be useful to you. So the problem we're placing should be somewhat familiar. It says you've replaced an old oil-fired furnace with an annual fuel utilization efficiency of 75% with a new one that's 85% efficient. Last year you used 900 gallons of fuel oil. This year, disappointingly, you used the same number of gallons. So, of course, our question is, what savings should we have expected? Could we blame it all on the weather, and how would we calculate that? Two, what would you have expected to have spent on the oil if you'd installed an efficient furnace last year? What would you have paid this year if you still had the old 75% efficient clunker? And what would you have had? What if you had installed a heat pump with a coefficient of performance of 2.5 or 200, 250, 250% efficient? So some information we need to know is what was the weather like last year? So we've given you the average temperature, but you should know by now that that's deceptive because it doesn't capture the variations in temperature, whereas heating degree days, which measure the difference from a baseline, and in the US we use typically 65 degrees Fahrenheit as a base temperature. So we have two different heating degree days, and obviously this year was colder than last year because there are more heating degree days. And we have the base information of the prices for the fuel oil, which we've decided have not changed in a year, which is not typical, and price for electricity, which is also not changed. And then we have 40.7 kilowatt hours of energy in a single gallon of fuel oil, and that is the same amount of energy as 139.6 kBTU, or thousands of BTU, in that same 1 gallon of oil. Okay, so it's both units are measuring the amount of energy heating value inside that fuel oil. And then with electricity, we know obviously in 1 kilowatt hour of electricity, there's 1 kilowatt hour of energy, but there's also 3.412 thousand BTUs in each kilowatt hour of electricity. So what I'd like you to do now is try working on this on your own. So pause and then resume the video, and we'll talk through the solutions. So the first thing we're going to need to do is have our is convert our energy usage from into constant units. So we want to have it in terms of energy usage per heating degree day. Now, for the time being, we can use the gallons. We know that in both years we used 900 gallons of oil. It's an energy unit in the sense that as long as we're still talking about oil, we can just stick with it as gallons. So 900 gallons in the first year divided by 5,400 heating degree days is equal to 0.167 gallons per heating degree day. 900 gallons per 6,000 heating degree days in the second year is equal to 0.15 gallons per heating degree day, so less per heating degree day. So our first question was, what savings should we have expected? So for that, we're saying savings is a difference, right? So our difference is going to be the difference between year one and year two divided by the original amount, and that's going to give us our improvement. So in this case, we can look at it as a percentage, and we can just take our gallons per heating degree day units and divide them by the original, and we get 0.1, which is not surprising because we improved our efficiency by about 10% in the combustion. So 10% of 900 gallons is 90 gallons. The price was $2.5 per gallon. So our savings should have been $225, but of course we got no savings because it was colder this year. And if we want to check ourselves against what we expected, well, we have now an 85% efficient appliance, and we had a 75% efficient appliance. That's 10%. So it all checks out. So what would we have spent on the oil if we had installed an efficient furnace last year? So this is where we're now taking those units of, in this case, gallons per heating degree day, and we're normalizing them by heating degree days. So we can take our 0.15 gallons per heating degree day that we got in our second year with our new appliance, and we can multiply it by the old heating degree days from the previous year, and then multiply that by our dollars per gallon. And what we should have spent in the previous year would have been $2,025. What would we have paid this year if we still had the old clunker? Well, we can again normalize again this time, but now we're taking the old condition where we were using 0.167 gallons per heating degree day times the heating degree days that we had in this previous year, which was 6,000 heating degree days, times the dollars per gallon. And so if we had not changed it out, we would have been paying $2,500. So we would have used more oil than we actually did. And then what if we had installed a heat pump? In this case, not a particularly great heat pump. It's only a coefficient of performance of 2.5, but okay. So we can take our gallons per heating degree day times the efficiency, right? Times, and that efficiency now is times the energy per gallon, right? And now we have it in kilowatt hours per heating degree day, right? So we've got the efficiency, which has no units. We have our energy use per heating degree day in gallons, but we're canceling that out with kilowatt hours per gallon. So now what our demand is. So remember, we're using the 85% efficiency. We're using that efficiency to say, well, that's what's actually demanded, right? Because we lose 15% as waste. So we're accounting for that and saying what the house actually needs is just 5.189 kilowatt hours per heating degree day. That's what it actually requires in energy. So now we can take that and we can say, well, we need to supply that, but with the efficiency of the new heat pump. So we have 5.189 kilowatt hours per heating degree day. We take our most recent heating degree days, which is 6,000 heating degree days, times the efficiency of the heat pump, which is 2.5, times the cost for a kilowatt hour of electricity, which is 18 cents. And had we installed the heat pump, we would have spent $2,241. So in this case, not a very large savings, and not a really great savings, but competitive. And of course, there are lots of benefits to heat pumps, such as not combusting things in your house. And of course, we could get a much more efficient heat pump. So I hope this kind of stepping through these calculations has been helpful to you. And